Ever wondered how medieval people built homes that survived brutal winters without insulation or heating systems? These master builders developed construction techniques using only natural materials. Their methods often outperformed modern building standards. Today I'm sharing revolutionary home building secrets that conquered harsh climates. Foundation and site selection. Medieval builders strategically selected building sites that provided natural protection from prevailing winds, while ensuring proper drainage to prevent foundation damage from freezing water. They positioned homes on slight elevations to avoid cold air pools and potential flooding during spring thaws. Stone foundations were laid deep enough to reach below the frost line, preventing structural damage from freeze-thaw cycles. Site preparation involved clearing vegetation and leveling ground using only hand tools, creating stable building platforms that could support heavy timber or stone construction throughout harsh winter conditions. Wall construction techniques. Medieval wall construction utilized timber frame buildings with wattle-and-daub infill that provided excellent insulation while using locally available materials. Heavy timber posts and beams created structural frameworks that could withstand severe weather loads. Wattle panels woven from flexible branches were packed with daub, a mixture of clay, straw, and animal dung that dried into weatherproof barriers. Stone masonry construction used locally quarried materials fitted together with lime mortar that sealed joints effectively. Double wall systems created air gaps that provided natural insulation while adding structural strength. These techniques produced walls that remained warm and dry throughout extended winter periods. Natural insulation materials. Medieval builders utilized abundant natural materials that provided superior insulation compared to many modern synthetic alternatives. Straw was layered between wall cavities, creating air pockets that trapped warm air while remaining lightweight and manageable. Moss gathered from forests was packed into gaps and cracks, expanding when wet to seal openings completely. Animal hair from sheep, cattle, and horses was mixed with clay to create insulating plasters that covered interior walls. Dried grass and leaves were bundled and placed in wall cavities where they provided thermal barriers throughout winter months. Clay and mud plasters created thermal mass that absorbed heat during day and released it slowly throughout cold nights. These natural insulation systems often performed better than modern materials because they managed moisture naturally while providing consistent thermal protection without chemical additives or energy-intensive manufacturing processes. Roof design and construction. Medieval roof construction emphasized steep angles that shed snow loads effectively while creating interior space for insulation and storage. Thatch roofing used locally available materials like straw, reed, or rush that were layered thick enough to provide waterproofing and insulation simultaneously. The layering technique involved overlapping materials so water would run off quickly without penetrating to interior spaces. Wooden shingles were cut from split logs and installed with overlapping patterns that created multiple barriers against moisture infiltration. Support beam systems used carefully calculated timber sizes that could handle heavy snow loads while maintaining structural integrity throughout winter storms. Ridge construction included ventilation systems that prevented moisture buildup while maintaining thermal efficiency. Roof pitch calculations balanced snow shedding with interior space requirements, creating designs that maximized livable area while ensuring structural safety. These roofing systems often lasted decades with proper maintenance, providing reliable protection that kept interiors warm and dry throughout the harshest winter conditions. Heating system integration. Medieval homes integrated heating systems that efficiently distributed warmth throughout living spaces using only wood fuel and strategic design principles. Central hearth placement utilized massive stone fireplaces that provided radiant heat while creating thermal mass that continued warming rooms long after fires died down. Chimney construction involved careful engineering that created proper draft while preventing heat loss through oversized flues. Heat distribution systems included stone or brick thermal masses positioned strategically to absorb heat during active fires and release warmth gradually throughout cold nights. Multiple fireplace systems in larger homes provided heating zones that could be controlled independently based on occupancy and weather conditions. Smoke management required understanding airflow principles that ensured proper ventilation while preventing dangerous carbon monoxide buildup in sealed winter quarters. Ash and ember management systems enabled safe fire maintenance while preserving coals for quick rekindling. These heating systems achieved remarkable efficiency through strategic placement and thermal mass utilization, often maintaining comfortable temperatures throughout winter months, using minimal fuel compared to modern heating systems that require constant energy input. Window and opening management. Medieval window design balanced natural light needs with heat retention requirements through strategic placement and weatherproofing systems that maintained interior warmth during harsh winter conditions. Window placement followed solar orientation principles that maximized winter sun exposure while minimizing heat loss through openings. Shutter systems provided multiple protection levels. Exterior shutters blocked wind and precipitation, while interior shutters added insulation layers during coldest periods. Door construction utilized heavy timber with multiple weatherproofing treatments that prevented air infiltration around frames and joints. Opening sizing calculations balanced ventilation needs with thermal efficiency, creating openings large enough for necessary functions while minimizing heat loss surfaces. Window covering materials included oiled cloth, thin animal skins, or later glass panels that allowed light while blocking wind. Weather stripping used natural materials like wool, moss, or animal hair packed around door and window frames to eliminate drafts. Threshold design created barriers that prevented cold air infiltration while managing water drainage. Multiple door systems included interior and exterior doors that created airlock effects, reducing heat loss when openings were used. These opening management techniques maintained indoor comfort while providing necessary ventilation and natural lighting throughout extended winter periods. Interior layout for warmth. Medieval home interior layouts were carefully planned to maximize heat circulation and retention through strategic room arrangement and multifunctional space design that concentrated warmth where families spent most time. Room arrangement positioned frequently used areas like kitchens and main living spaces adjacent to primary heat sources, ensuring maximum comfort during daily activities. Sleeping areas were located near heat sources or above heated spaces, where warm air naturally accumulated through thermal stratification. Storage integration provided insulation benefits by positioning storage areas along exterior walls where they created buffer zones between living spaces and cold outdoor temperatures. Multi-level design utilized natural heat-rising properties by placing sleeping lofts above main living areas where warm air collected, creating comfortable sleeping conditions without additional heating. Interior partition walls were positioned to channel warm air throughout homes while creating separate functional areas for different activities. Ceiling design incorporated spaces for warm air collection while maintaining structural integrity and preventing heat loss through roof areas. Floor construction included raised platforms that elevated living areas above cold ground contact while creating air spaces for insulation. Furniture placement blocked cold air infiltration while directing warm airflow patterns throughout living spaces. These interior layouts created thermal zones that maximized comfort and energy efficiency while accommodating family living requirements throughout brutal winter conditions. Weatherproofing and sealing. Medieval weatherproofing techniques utilized natural materials and traditional methods that created effective barriers against wind, moisture, and cold air infiltration without synthetic sealants or modern materials. Natural caulking materials included mixtures of clay, animal hair, and plant fibers that expanded when wet to seal gaps completely while remaining flexible during temperature changes. Joint sealing techniques involved careful fitting of construction materials that minimized gaps while using organic compounds to fill remaining spaces. Exterior treatment methods included lime washes, pine tar, and linseed oil applications that protected wood and stone surfaces from moisture damage while maintaining breathability that prevented trapped moisture problems. Maintenance schedules coordinated weatherproofing renewal with seasonal cycles that ensured protection remained effective throughout harsh weather periods. Chinking techniques filled gaps between logs or stones using materials that accommodated structural movement while maintaining weatherproof seals. Vapor barrier systems used animal skins or tightly woven fabrics that prevented moisture infiltration while allowing controlled air exchange that maintained healthy interior conditions. Foundation sealing prevented ground moisture from entering structures while ensuring proper drainage that protected building materials from rot and decay. Wall surface treatments created water-resistant barriers that shed precipitation while maintaining thermal properties essential for winter comfort. These weatherproofing systems required regular maintenance but provided reliable protection that kept medieval homes warm and dry throughout extended winter periods, using only natural materials and traditional application techniques. Tool making and construction equipment. Medieval builders created specialized hand tools and construction equipment using traditional blacksmithing and woodworking techniques that enabled precise construction work without power tools or modern equipment. Hand tool creation involved forging axes, adzes, chisels, and planes that could shape timber accurately while maintaining sharp edges through heavy use. Measuring techniques utilized body-based measurements and proportional systems that ensured consistent construction without standardized rulers or levels. Rope and plumb bob systems provided accurate vertical references for wall construction and structural alignment. Wooden squares and measuring sticks created standardized measurements that coordinated construction activities between multiple workers. Lifting systems included pulleys, levers, and ramps that moved heavy materials using mechanical advantage principles rather than powered equipment. Stone cutting tools included wedges, hammers, and chisels that could shape building stones to precise specifications. Timber shaping equipment included draw knives, framing squares, and specialized planes that created joints and connections with remarkable precision. Mortar mixing required wooden tubs, measuring containers, and mixing tools that combined materials to proper consistency. Sharpening systems maintained tool effectiveness through whetstones, files, and tempering techniques that preserved cutting edges throughout construction projects. Tool maintenance included handle replacement, blade resharpening, and rust prevention methods that kept equipment functional in harsh working conditions. Construction equipment storage and organization ensured tools remained available and protected throughout multi-season building projects. These handmade tools often produced more precise results than modern power tools while requiring only human energy and traditional craftsmanship skills that could be maintained and repaired using local resources. Community building systems. Medieval construction projects utilized sophisticated community cooperation systems that pooled resources, skills, and labor to accomplish building tasks that individual families could not complete independently while creating social bonds that strengthened rural communities. Cooperative construction methods included barn-raising events where entire communities gathered to complete major structural work in single days through coordinated group effort. Skill-sharing arrangements connected master craftsmen with apprentice builders who learned traditional techniques while contributing labor to construction projects. Specialized trade coordination brought together carpenters, masons, thatchers, and other specialists who collaborated on complex construction projects requiring multiple skill sets. Resource pooling enabled communities to acquire expensive materials like iron hardware, quality timber, or specialized tools that individual families could not afford independently. Labor exchange systems allowed families to contribute work to others' construction projects in return for assistance with their own building needs. Knowledge transfer between experienced master builders and younger generations preserved construction techniques while adapting them to local conditions and available materials. Project planning involved community decisions about construction timing, resource allocation, and work schedules that coordinated multiple building projects throughout construction seasons. Material sharing included cooperative harvesting of building materials like thatch, timber, and stone that benefited from group effort and specialized knowledge. Quality control involved community oversight that ensured construction met safety and durability standards while maintaining traditional building practices. Problem-solving cooperation addressed construction challenges through collective experience and creativity that found solutions beyond individual capabilities. These community building systems created social networks that sustained rural populations, while accomplishing construction projects that provided secure shelter throughout harsh winter conditions using shared knowledge and cooperative effort. Repair and maintenance systems. Medieval homeowners developed systematic repair and maintenance programs that preserved building integrity and winter protection through preventive care, emergency repairs, and long-term preservation strategies using available materials and traditional techniques. Preventive maintenance schedules included seasonal inspections that identified potential problems before they became major issues requiring extensive reconstruction work. Roof maintenance involved regular thatch replacement, shingle repair, and drainage system cleaning that prevented water damage and maintained weatherproofing effectiveness. Wall maintenance included repointing masonry joints, replastering damaged areas, and checking timber connections that could fail due to weather exposure or structural settling. Foundation care involved drainage maintenance, stone replacement, and erosion control that protected structural integrity from ground moisture and frost damage. Emergency repair methods addressed winter damage from storms, heavy snow loads, or extreme temperature fluctuations that could threaten building safety and occupant comfort. Material replacement strategies included stockpiling repair materials and knowing local sources for emergency supplies needed to address unexpected damage quickly. Chimney and heating system maintenance ensured safe operation while preventing dangerous conditions like chimney fires or carbon monoxide poisoning that could threaten occupant safety. Window and door maintenance included weather stripping replacement, hardware repair, and frame adjustment that maintained thermal efficiency and security throughout winter conditions. Tool maintenance ensured repair equipment remained functional and ready for immediate use when problems required quick resolution. Documentation systems tracked maintenance activities, problem patterns, and effective solutions that guided future repair decisions and preserved institutional knowledge. Quality control during maintenance work ensured repairs met durability standards while maintaining original construction integrity and thermal performance. These comprehensive maintenance systems enabled medieval homes to remain functional and comfortable throughout decades of harsh winter conditions while preserving building value and occupant safety through systematic care and timely repairs using traditional materials and proven techniques.